Right, we're going to look at these questions which have been predicted to come up in the next paper or two of the GCSE. So we'll start off with this question here, which is a question on correlation. And with correlations, what you want to do is sort of look at the trend of the shape of all the crosses. And we can see that the trend of this shape is that a positive one. So we can say it's a positive correlation. Okay, and the next bit it asks for is what is the greatest amount of rainfall in 1 week? And the greatest amount of rainfall in 1 week that we can see is, we go this way, is this one here. And that's looking at being about 12.8. There's 12, there's 13. So that's about 12.8 millimeters. In another week, there was 6 millimeters of rain. Estimate the number of umbrellas sold. So what you need to do for this is you need to draw your line of best fit and try and work out what a line of best fit would be. And there's quite a variety of lines you could have. And we want to just try and make sure that it mimics the data. So roughly half the data is above and below the line. There will be a wide variety of answers to this question. As long as you draw your line, it looks sensible, you'll get the marks. And you must show how you get your answer to the 6 millimeters of rain, how many umbrellas were sold. So you draw a line up, make sure you draw a line across. And this comes out at around about, so we've got 60, we've got 45, so that's 15. And they've got 5 squares, so each square is 3. So I've got roughly 2 lots of those squares are 3, so that means I've got 6 out of the 45, which gives me 51 umbrellas sold. It says, explain why it might not be appropriate to use your line of best fit to estimate the number of umbrellas sold in a week with 25 millimeters of rainfall. Well, 25 millimeters of rainfall is way beyond the end of our data, so we are extrapolating, so we have no data. Or you could say this value lies outside the range of our data. So we would be guessing. Okay, so that's the first question. Let's move on to question 2. Write this number in standard form. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9 places we would have to move the decimal. So it's 5.93 times 10 to the 9. And right, this is an ordinary number. Now we've got to move the decimal and to create a negative standard form number. So that means it's going to get smaller. So we're going to move it 1, 2, 3, 4. So you can imagine putting the noughts in, and there's a decimal. So we create that. Let's just write that 8024. Remember, you're going to go 1, 2, 3, 4 decimal places. So there must be a nought there, a nought there, a decimal place there, and a nought here. Now we need to work out the value of w in this case. So we've got w squared equals 2 times 10 to the 6 times 6 times 10 to the 5 over 2 times 10 to the 6 minus 6 times 10 to the 5. I'm going to put this into my calculator, and to make it easier, I'm going to put brackets around the top and the bottom. So let's just do that. Now you will have an EXP button in your calculator, but an exponential button, but I don't have on this, so I'm going to write it in as 2 times 10 to the power of 6. If you want, you can write that. Times by, careful with this, I've just got to move that across to there. So I'm going to have times 6 times 10 to the power of 5. Don't be put off by the dots, they all mean times. And you can notice it's giving me my answer in standard form. Now I want to divide that by everything on the bottom. So I'm going to put 2 times 10 to the 6 power in there. And I'm now going to subtract 6 times 10 to the 5. To the power of 5. And what I did do is I forgot to put my brackets, but it doesn't really matter because a division sign implies brackets anyway. And it gives me an answer, and that's my answer for w squared. So I've got w squared is equal to 8, what's that going to be? That's going to be 857,142, 857,142 point various values. And now, therefore, we need to square root that answer. So let's put that down and get a square root in to our answer. And that gives us 925.8. Now it says to two significant figures, so there we go, two significant figures. This is 5 or more, so we round up to 930. But it says in standard form, so our answer is not 930. We need to put it in standard form, which is 9.3 times 10 to the 2. Because we're going to move our decimal place 1, 2 places, so therefore it will be times 10 to the power of 2. Question 3, we're going to use our calculator to find this. Nice easy question. All you've got to do is just make sure your thing looks on your calculator looks just like theirs. So you've got 39.3 all squared, and then I'm going to subtract from that. I want to put it under the bracket and not there. There we go, it's now under the bracket and not in the power. And we're going to subtract from that 1.24 squared. And that gives us 39.280. So 39.280. What else did I get? 280, 4327. 4327. 1, 2, 3, 4, 5, 6, 7, 8, 9. Your calculators have one more place generally. So it's going to come out as a 9 if it rounds up. Or it might come out as 8 if it truncates, depending on what your calculator does. Most calculators will round. Right answer to 3 significant figures. So there we go. We know we need to round up. So that's 39.3. Question 4. We're going to use a ruler and compass to construct the bisector of the angle ABC. That's going to be quite tricky to demonstrate that on this screen. Essentially, you're going to put a compass point here, and you're going to mark off here, and you're going to mark off here, exactly the same distance. These two distances must be exactly the same. And then we're going to put a compass point here, and we're going to draw an arc. Compass point here, draw an arc, and generally the line through where those two arcs cross will be the angle bisector of ABC. You want that to be equal to that. So remember, compass point here, draw an arc. Compass point here, remember not to change your length of your compass. Draw an arc there, and you get your answer, this line. Diagram shows two lighthouses. A boat is within 8 miles of lighthouse A, and it's the same boat within 6 miles of lighthouse B. So essentially what it wants you to do is draw a circle, okay, around here. 1 centimetre is 1 mile, so you've got to be 8 centimetres from here. So we draw a circle that's 8 centimetres from here, and we draw a circle that's 6 centimetres from here. Okay, and it's not accurate, I've done it freehand, and you're going to shade the area in between those two. You'll need to make sure you've got your compass point here. This distance is 8 centimetres when you draw your circle. Compass point here, and this distance is 6 centimetres when you draw your circle, and you will get the right answer. Question 6. A cylinder has a diameter 12 centimetres and height 14 centimetres. Cube has length side y. The cylinder cube has the same volume, so we need to work out the volume of each. Now the cube is just, if it's a cube, it will be all this measurements will be y, so the volume will equal y cubed. And we know that that's going to equal the volume of this. And the volume of this is going to be pi r squared h. Okay, pi r squared is the area of this circle times by the height, because this is actually a special case of a prism. So r is equal to 6, so we're going to get pi times 36. R squared is going to be 36 times by the height, which is 14. And we're going to find out y. So y will be the cube root of all of that. So get our calculator. And we're going to do our nth. Didn't work like that. Let's just put that in, put 3 in there. And we want pi times 36 times 14. And we get 11.655. Doesn't actually give us a degree of accuracy to use it. Generally, GCSE will tell you a degree of accuracy to round this to, and you should always give your answer to more figures rather than less. At least if you give it to more figures, they will give you credit for answer rounds to. Let's say it's 3 significant figures, so it will be 11.7 centimeters. Shown below is a triangular prism. Volume of a triangular prism. A prism is the cross-sectional area times by the length. So we want to find the area of that triangle. So it's a half times 6.8 times 8.5, and then times by the length 21.5. Let's do that. Let's do another line. 0.5 times 68 times 8.5 times 21.5, and we get 6,213.5. Doesn't ask us to round. 6,213.5 is our answer. I'm just going to check my numbers. It's a good idea for you to do the same. So half times I've done 68, so there you go. Good to check. 6.8 times 8.5, was that the right number? Times 8.5 is correct, times 21.5. So it gets 621.35 on this. There we go. So always good to just check your answer against the working. Find the lowest common multiple of 60 and 72. There's many ways to do this. One way is to prime factorize. So we can prime factorize this down and do the same here. Okay, so lowest common multiple is a number they must both go into. So if there's a number that's common to both, so if you're going to find a number these both go into, then actually anything that's common will be common in that new number. So what I've done is I've highlighted the 2 and the 2 here, they're common. The 2 and the 2 in here is common. And we've also got the 3 and the 3 common in both the new number. So those are common factors of both numbers. So both numbers are going to have 2 times 2 times 3 as prime factors of both numbers. But also, to get the 60, I need to times by this 5, this number. And to get the 72, I need to times this number by 2, another 2, and another 3. So therefore, the number they must both go into must be times by 5, and also times by another 2 and another 3 to get our lowest common multiple. So an easy way to remember this, look what's common to both and only use once, and then everything else we just tag on the end, and that gives us our number. So we've got 2 times 2 times 2, which is 8. Then we've got times by 9, then times by 5. So it's going to be what? That's 8 times 50 minus 40. That's 400. That's going to be 360. And you can just check. I haven't made a mistake. Just put this over here, and we do 360 divided by 60 is obviously correct. You can just do 360 divide by 72 to check. And you can see that's 5 as well. Next one. Question 11. On a grid, draw x plus 2y equals 6 from x minus 2 to x is 2. So to get our range of y values, let's put x is minus 2 in. So x is minus 2, that gives us minus 2 plus 2y equals 6. So 2y will equal 8. So y will equal 4. So we have a point minus 2, 4. And then put x equals 2 in. And you get 2 plus 2y equals 6. So 2y will equal 4. So y will equal 2. So we have another point. And that's going to be 2, 2. So our y values only need to go from 4 to 2 in this range. And x values only need to go from minus 2 to 2. So and got plenty of space in here if I actually draw it down here. And I'm going to draw y-axis in here. There's 1, there's 2, there's minus 1, there's minus 2. You could have minus 1 on the y-axis, but we don't need it. So that's going to be 1, 2, 3, 4. And I need to plot the point minus 2, 4. I need to plot the point 2, 2. And we get a straight line in between those 2 points. In fact, we could draw it even further. I'm just going to rub that out to get that again. There we go. There's our straight line. And we only actually have to show between minus 2 and 2. You could extend it further if you wished. It wouldn't matter. Well, this question, I'm going to make the y's the same. I'm going to times the top one by 3 and the bottom one by 2. And then both my y's will be 6's. So I'm going to get 15x plus 6y equals minus 102. When I times that by 3, times this by 2, I get 8x plus, sorry, not plus, minus 6y equals 82. Minus 82 even. Minus 41 times 2 is minus 82. Add these together, then the y's will cancel. And that'll leave me 23x equals minus 184. I'm going to guess that goes into that 8 times. So x equals minus 8. You can just check that. 8 times 20 is 160. 8 times 3, 24 gives me my minus 184. So if x equals minus 8, let's put that into, doesn't really matter which one we put into. Put into the top one. So you get 5 times by minus 8. Bring it into here. Plus 2y equals minus 34. So that gives me minus 40 plus 2y equals 34. Add 40 to both sides. 2y will equal 6. So y will equal 3. And then you could always check our answers work in the next one. So you get 4 times minus 8, which is minus 32. Minus 3 times 3, which is minus 9. And that adds up to minus 41. So this is correct. And for today, question 10, which I missed out earlier, make V the subject of the formula. So I'm going to basically work for, when you do your order operations, you work from the inside out to get things done. And then undoing them, you work outside in to V. So let's get rid of this half. Never like fractions. It's right on the outside. So let's times straight by 2 to get 2s equals u plus vt. And I'm going to divide by this t to get rid of that. So 2s over t equals u plus v. And then I'm going to subtract u. So 2s over t minus u equals v. That's one form of the answer. Now, if you multiply out the brackets first, what you probably would have got is s equals a half ut plus a half vt. and you could subtract that first to get s minus a half ut equals a half vt. We could times that by 2 to get 2s minus ut. So times this by 2, get 2s. Times this by 2, well, you just cancel out that half to get ut. And that leaves vt. And then we need to divide by t. So 2s minus ut over t equals v. And this is actually exactly the same answer as this. Okay, if we turn this one into a single fraction, we need to times top and bottom of that. Imagine that's u over 1 by t. So you get 2s over t minus ut over t, which equals 2s minus ut over t. It doesn't matter which way around you do it, you can still get the same equivalent answer.